In this video, we're going to take a look at SurfaceFollow. SurfaceFollow allows particles to hug the surface of a piece of geometry. And you can see we've got some red particles out here and a piece of ground, which is this big brown plane. And we've got 4 dynamic sets to control this. We've got born to create the particles. Follow node tells the particles to follow a point helper. That's going to kind of drive them around the surface. And then we've got the actual surface follow, where the particles stay on the surface and then keep apart, which we use to keep the particles spread out from each other. Let's go ahead and take a look here in born. We've got we're doing a pistol shot of 10 and setting a geom instance to set their piece of geometry. It's this axis helper, so we can see which axis is pointing which way for the particles. Let's go ahead and look at the follow node. The follow node takes the red particles and compares them to this point helper, and using a distance condition, we're going to output the direction. And you can see we've got those position inputs flip-flop. That means that the direction that's calculated is from the particle toward the node, as opposed to from the node to the particle, if we had those flip-flop. But the way they're set up now, it's calculating from the particle to the node. And then that direction is being fed into the velocity, which affects those particles. So it's telling the particles which way are they going to go. They're going to head toward that node. Let's go ahead and just jump up into the top view here, and we can see that those particles are going to go ahead and chase after him. We could have used follow. We could have used position follow. This is just one way to set it up. And next up, we've got the actual surface follow. We're going to tell the red particles we want you to follow a surface. Surface follow has a requirement of a floor node, so we've got a node here that points to this plane. And surface follow's got quite a few parameters. Let's actually change views. Okay, he's got what's called a setting up. This is for dictating how far from the surface the particles are going to follow. Sometimes you want the particles to be below the surface if it's an ocean or something, or way above if it's a land speeder or something. Anyway, we're going to set that to 1. That can all be controlled dynamically. It's got all these inputs matching all these parameters, so you can just pass unique values in if you need to, or calculate other values. And then we also have the alignment settings. This alignment is very much like the alignment operator. This is going to tell the particle which axis we want to be pointing vertical or perpendicular to the surface normal. Of course, we can invert that and whip them around, but then we can't see them. There they are. And then we've got the travel axis. This will kind of determine which way they are pointing as they're heading. It's going to use their y-axis. And then we also have speed. Speed is going to allow the particles to evaluate how fast am I going to respond to the surface. Lower values are going to kind of make them drunken and spin around a little bit. Very low values will make very wide circles. Speed of 1 is good just to track it in a fast update. And then subsample output. We're going to take a look at this in a minute. This is how we're going to have the particles born trails on the surface. Anyway, the next rule we've got is the keep apart. Keep apart uses a p-pass AB set to so that the red particles, and right now it's set to all, so each and every red particle is going to evaluate against every other red particle and calculate a repulsion balance. This is another dynamic operator that's great for keeping particles spread out from each other. It can also kind of simulate very quick collisions, or kind of fakish collisions. Anyway, what this is going to do, it's going to go ahead and kind of push the particles apart. We've lowered the bounce and the bounce elasticity. This will kind of prevent them from jumping back in toward each other. Anyway, you can see we've got an animated camera that tracks them. You can see that y-axis from the surface follow is their travel axis, and z is pointing up. And you can see them hugging that terrain. Let's go ahead and turn on wireframe for a sec. And then they whip around, and all the while they are following this node, remember. trying to track him down. Okay, now let's go ahead and we're actually going to set this up a little bit differently. We're going to tell the born, we're only going to born one particle, and we're going to come down here to the SurfaceFollow and look at the subsample output. What this determines is how fine is that surface evaluated, just based on the particle, his output. See, all of these sub-position, sub-velocity, sub-normal, etc. These are all calculated from the particle's position, and based on this subsample length, how often is it calculated. So if we go ahead and set this to maybe 5, and then we're going to go ahead and turn on this other position born operator, which is going to born some trail particles. Trail particles, let's go ahead and set those to kind of a greenish color so they don't blend into the brown, or maybe more of a yellow. And we'll go ahead and enable that. And right here we go ahead and we see one particle being born, and now you can see it's kind of dropping little particles as it goes. Let's zoom in up here. And this is good, but we probably want a little bit finer resolution. So what we'll do is on SurfaceFollow is we're going to drop this down, and you can see that as we lower it, it's adding more steps of evaluation in there. And you can go quite low. And we'll just go ahead and use 1 for right now. And so what this will do is we're using this sub-position output with a sample length of 1. So every 1 max unit distance, we're going to output a position value. And position born is set to pistol shot of 1 per call. So every time he gets a new position coming in, he's going to go ahead and born one of these trail particles. Now let's go ahead and let's actually set the sample length to 2, because now we're going to come back to the red being born, and we're going to go ahead and born several. Well, let's do 100 of them. That's my camera. And now we can see as these guys start walking, they're going to leave quite the trail behind. Something we might do to add some variation to this, we can come over here and tell SurfaceFollow that we want to input a random, we've got the master dynamic edit, let's turn on edit on the fly. We want the SurfaceFollow to use a random sub length from anywhere from 1 to 2, and we want that to be per particle per animation. So we'll turn on per animation and make that particle connection. This way each particle is going to generate its own random value only once the whole animation, and that value will be between 1 and 2. So now this is going to add quite a bit of variation in here. Let's go ahead and see what happens if we go ahead and increase this even more. A little hard to tell with 100 particles, but the difference is there. This is also one of those cases where you might actually want to generate a new value per frame or per call. Because we have that particle input coming in here, we can go ahead and use per frame or per iteration. This will still generate one unique value per particle. It just does it every frame or every subsample. So even set to frame iteration, kind of hard to see the difference there, but anyway, so this is kind of the basics of SurfaceFollow. Just remember that you've got all these sub pieces of information being sent out based on the sample length, and of course you can drive any of these other inputs dynamically, just like any other operator in TP. So it's very powerful for making crowds follow on the surface, for water follow on surface, syrup, etc. So very useful. All right.